Hey guys, how are you going? Well, let's start section 6. We're doing graphing. Okay, let's go and try this one. Drawing cubics. 6 graphs of factorized cubic functions. So in this case, most of the questions already factorized, so you don't have to touch too much. But if you have y equals x cubed plus 2x squared minus 3x plus 10, before the factorization, if you have polynomial form, you have to factorize first. Okay, before you apply any of these. We'll go this and check again one more. Okay, let's do that. Sketch should include, it's always same with linear, quadratic, cubic, doesn't really matter. X and Y intercepts. Okay, so X, Y intercepts. So x-intercept when y equals 0, isn't it? So in that case, when y equals 0, we only know when we have the factorized form. So to get x-intercept, you actually need to factorize it. Factorized. And y-intercept when what is 0? X equals 0. Good guys. Therefore, I don't have to really, in that form, 0, 0, 0, whatever number left is y-intercept. I don't have to even do it. Y-intercept is 10. Therefore, 0 and 10. That's y-intercept. Okay, that's quite simple enough. The behavior of the function, general, okay, we'll go this together. General location of turning point, yeah. We're not gonna go more specific ones. We just draw roughly and then find, I don't think we actually need to indicate local maximum and local minimum point here. Okay, but we just draw roughly. I'll just go this one first. Positive cube, when we y equals x cubed, yep, that's positive. When I say positive, your highest degree, which is cube, is positive. Good. Then I will have this shape. When x increase, it's gradient, isn't it? When x increase, y also increase graph. Sorry. General pattern, when x increase, y increase. General pattern. Or easiest way you remember, I start from increasing, not decreasing. Okay? So just remember that. That's when x cubed is positive. When x cubed is negative, so something like that, going down graph. When x increase, y decrease. Or your starting point, the easiest way is you draw down from the start. Going down. Positive, negative. You're not gonna forget. Okay, let's draw that positive one. Can you draw it? Yep, positive, going up. But think about linear. Negative, going down. Positive, negative, negative. Okay, it's like a wave. Think about wave, but the wave is going up, wave is going down. That's pretty simple enough to explain that. but that shape gonna be slightly different. Depends on how many x-intercept we have. So I just cover that part. You can read that. Yeah. And sometimes there are not two turning points, and there is a point of inflection. A point of inflection. Can you write this down in your exercise book? And then we'll draw that. The point of inflection is when your growth is 0. So gradient at that point becomes 0. I will show you when you have that later, okay? But can you see that? Yeah. So a point of inflection happen when gradient becomes 0 here. And we don't learn about more specific gradients for level 3, but at least we understand what is point of inflection means. Yeah. And we'll underline that this occurs when there is only one x-intercept, which I will talk about that. Only one x-intercept here. The easiest way to remember this, because we're only doing patterns, rough drawing, is already factorized. Yep, this is already factorized, isn't it? So we have 1, 2, 3 roots or solution. So y equals a, x minus b, x minus c, x minus d. X minus b equals 0, x minus c equals 0, x minus d equals 0. Can make y equals 0, which means x equals b, x equals c, x equals d. When x equals b, c, d, which is b, c, d here, we have y equals 0, 0, 0. Y is 0 here, isn't it? When you look at it. So that's like we're getting x-intercept. Or we got 3 roots or solution. When I can see there is 3 bracket, means we got 3 solutions. When we have 3 solutions, where B, C, D is the biggest, and next, or because of that, isn't it? You can see that. It doesn't mean anything here. It's just a number increase that way. We know that. I told you we should have positive graph here. X gonna be positive, isn't it? X times x, positive x. So I know increasing. So that's general pattern. That's first thing you need to figure out. Okay, this graph will have that shape since that is positive x cubed. Okay? And then I know the 3 brackets, which means we got 1, 2, 3 solutions. 3 brackets, 3 solutions, which means we will have 3 intercept. X and y, we will have 3 touching points. So 1, 2, 3. 1, B, C, D. Does it make sense? Yeah. We just fit in here, but we have to touch how many times? 3 times. You can approach that way. That's probably the easiest way. Yeah. Draw that first, and then go and figure out how many intercept, and then we just plugged in 1, 2, 3. Good. Okay, go second one. Repeated factor. What they're saying is that is repeated. X minus b. I mean, I can write down x minus b, bracket x minus b. Still same answer. So it's repeated. Another thing I can say, there are 2 brackets here, isn't it? Yep. Only 2 answer exists. X minus b equals 0, x minus c equals 0. X equals b, x equals c. I only have two roots, two solutions, which means I only have two x-intercept. Okay, let's go and figure out x square x. Okay, as long as a is positive, which we assume this is gonna be positive graph. So going up, positive. We figured out up, positive, isn't it? Positive graph look like that. Still increasing graph. Okay, increase. And then that touches twice x and y. We have to touch here twice. If I go like this, we're touching 1, 2, 3. Which case we only touch twice. What could be the possibility here? I will reduce this bit down. When I move a little bit that way, touch. If I draw that way, that touches only twice, isn't it? Yep. So when you have two brackets, one is repeated, square, you will have this form. It's the same, but that touching here, like this. The where B, C, yes, that makes sense. Bigger turning point is B0. Oh, don't worry about that part at the moment. Okay. So that makes sense? Yeah. Just go up and touch there. If this is negative, then that's repeated. Similar way, negative is what? Going down, isn't it? So going down. Oops. Negative will have go down, same thing, touch, and touching once that way. So I have 1 and 2 rather than this repeated one, just touch, because we have to draw graphs touching twice. We have to draw that way. Okay, positive and negative. Try that a couple of times. Try to draw it, and you'll figure out. And if there is only one factor, which means we got only one x-intercept touching x only once. Y equals x minus 2 cubed 0, 2. When x is 2, that's x-intercept, and that's positive, isn't it? Positive graph. So previously 1, 2, 3, touch it 3 times. You touch twice, 1, 2, isn't it? Now our possibility is we're going up and touch once and go up like that. So when we have 3 brackets, 3 solution, 1, 2, 3, 1, 2, 3, 1, 2, 3. And we have repeated 1, 1, 2, 1, 2. We have only one solution, cube, 1 bracket there. We only touch here at this point, 1. So please remember. Can you draw that negative one as well? So that is positive case. What about negative? Can you do it in your exercise book? Negative point. Yeah, you do it first, guys. Have you done it? Yep. Hopefully, practice a couple of times more because you're not really get used to it, but you need to know that general pattern. If there is only one factor, there is a point of inflection because yes, because of the shape, we have one that point. A point of inflection, we have gradient equals 0 point, the flat point here. Doesn't grow when x increase, y increase 0 at that point, which is in this case x-intercept here. But all you need to know, just patterns. That's gonna be probably good summary as long as you can draw that. Try that a couple of times more so you're able to draw these patterns. Okay. The graph may also have local maximum. They use the word local and local minimum, but this is not necessarily absolutely maximum and minimum because so in this going up and down, isn't it? I mean, we don't know. There is no domain or range in this case, so it's going down all the way unless there is domain and range. So the maximum, minimum and maximum point gonna exist somewhere here. Depends on the condition. However, I know around that area that is local maximum. We just compare these 2 points, turning points. Yeah, local maximum, local minimum. The 2 turning points there. Whatever the bigger one, we call local maximum. Smaller one, local minimum. That's probably simple enough to understand that way. So that's we're just comparing 2 turning points here. All good? How do we know turning points? Turning point form, isn't it? But do we learn that here? Not really. We only learn turning point form quadratic. I think we're gonna see the next chapter section. Next section, yeah, we talk about that, but only one shape. So we don't really go too much for cubic. Let's solve some questions. For example, 1, 2, okay. 1, 2, 3 bracket, isn't it? 3 solutions. 1 minus 2 minus 1. How do I know? Make that 0. Make that 0. Make that 0. So, and x times x times x, x cubed gonna be positive, isn't it? So therefore, positive. And I draw that, yeah, that shape. And then I know I have minus 2, minus 1, and 1. So I'll have this shape. Same as that. Simple enough? Yeah. And then if I want to know x-intercept, which we done, y here, y-intercept when x equals 0, therefore y equals minus 2, y-intercept is minus 2 here. I can indicate it. Good. Okay. Sketch the graph showing all intercepts. From that, makes that how many brackets here? 1, 2, 3. Therefore, we have 3 x-intercepts. Good. 2, 3, minus 5. So I know this will touch. I did that here. Minus 5, 2, and 3. I'll touch those 3 points. Okay? And then, is this positive or negative? X times x times x makes x cubed is positive. Positive, therefore, going up shape. It's going up like this. So I should draw a bit better, like this. Something like that. Yeah. Shouldn't make too flat that way. Yeah. And what about y-intercept is going to be somewhere here, isn't it? Yep. When x equals 0, plug in 30. So therefore, y-intercept is 30. So I got x-intercept and y-intercept. Also, general position from x cubed is a positive or negative. That's all I need information, and I can draw it. All good? Okay, next one. Can you do example 2? Example 2, yeah? Can you do that first? Think about it. There are 2 brackets, one is repeated. 2 x-intercepts. Yeah. Can you do that? When x equals 6, when x equals 4. You continue first. Okay. You pause it and do first and come back. Okay. And is this positive or negative graph? X times minus x. So x cubed minus x, I should have minus x cubed here. Sorry, square x, but we have negative there, negative x cubed. So this is a negative, not going up, going down, down. So something like going down, okay, going down graph. And then you all go and check x-intercept, y-intercept. X-intercept, we already get 6 and 4. Yeah, I can get it straight away, or you can write it down that way. And the y-intercept, when x equals 0, 144. Therefore, I know 144, 46, negative, going down. So general form is this, isn't it? No. Why? Because remember, 2 solutions. What was the general pattern? 1. Oops. This. You remember that? Yep. General pattern when that touches. So we'll go down. Oops. Go down. And up. Usually, if I have one more, I should go here. However, now we'll just turn here. It's like what we did there. Touches it. The other one doesn't go up and down. It just touches down straight away in that point to make 2. And it's going to be the squared one. The repeated one will have that, but sim-sum is always that pattern. So I don't think you need to remember that part. Okay, so we'll continue. If something different question come up, I'll let you know. Does it make sense? You should be careful. 1 dash 3 solution. We have only 2. So 1, 2, and down. And that is repeated points. 6. Sounds okay? Yep. Next one. So the last pattern, when we have, so I'll just use that. We delimit one bracket, yep, one x-intercept is a negative, positive. Oh, it's clear, it's negative there, negative, down. Okay. When x increase, it's going down graph. And then x-intercept, hold on. Oh, y-intercept, we'll just do y-intercept here because I did it first, doesn't really matter. Y-intercept and x equals 0, I got 27. So I know we'll touch 27. And x-intercept when x is 3. And remember, negative, we can have 3 possibility, 3 solutions. 1, 2, 3, wasn't it? 2, 1, 2. 1 bracket, 1, 2. A point of inflection here happening, isn't it? I mean, we can get something like that, have only 1 as well, but don't worry about that yet. So far, are you guys okay? So I know this is negative going down, and then going down the way. I draw this better, down that way. Follow the pattern. Sounds good? Yeah. So there's only 3 patterns we learned. That's why it said this was good summary. 3, 2, 1. Get x-intercepts and y-intercept. Get the points. You should know the general pattern here. 1, 2, 3. 1, 2, 1. Negative. 1, 2, 3. 1, 2, 1. As long as you remember this, you should be fine here. The last question, question 4, please do that. But first, try that. Do we have factorized form? No. We don't. So what do we need to do first? You factorize it. Okay? You do it first and come back. Pause it and do first. Okay. How was it? Hopefully you did okay. Write down what you need to do. If there is no factorized form, you factorize cubic. Okay? How do we do that? First, trial and error. You have to do it that way, which means you plugged in. Usually 1 minus 1, 2 minus 2. Somewhere there has to be quite simple number. You don't have much time. In this case, minus 1 will give me 0. Okay? Minus 1. Therefore, x plus 1, since x is minus 1 here, everything becomes 0. You put opposite sign of that. X plus 1 is a factor. Good. So I have one factor. And then I need to find another factor. What do? You can use long division, short division, synthetic division. Since x plus 1 looks simple enough and coefficient in front of x is 1, I can use synthetic. Synthetic is fast. So write down 2 minus 11, 7, 20. There is no empty spot. So I can just write it down. 2 minus 11, 7, 20. And then x is minus 1. So minus 1, write it down. Times 2, come down. Minus 1, 2. Minus 2, minus 13. Minus 1, minus 13, 13. 20, minus 20, 0. Therefore, x plus 1. 2x squared minus 13x, 20. I did synthetic division here quickly. Much faster than long division, As long as you use short division or synthetic division, I'm happy. Be honest, when I do algebra, I usually use short division. Yeah. Long division takes too long. Takes too long. No. In the future, you probably use short division. But in that case, synthetic is quite simple and easy, so I just used it, and it's new. I introduced, so I use more for you guys. Long division takes too long. Why you spend more time for that? Okay, so all the way. I mean, that's the only way you can do. That's okay, but the possibility, this exam can ask pick one, and they can actually ask you use synthetic. Never know. Didn't happen before, but never know. All right, and then I factorize that. 2, 1, minus 5, minus 4. Hopefully you're able to do that now. And now I know minus 1, 5 over 2, 4. They are x-intercepts. I got 3 roots here. And I know this is positive. How here? Yeah. X in front of x cubed. That's positive. So going up. Then y-intercept equals 20. I don't even need to work that out because 0, 0, 0, 20 when x equals 0. Only number there, 20. Therefore, I can go and draw 23 roots in order, small number to larger number, yeah. And then positive going up, so up and down, 1, 2, 3. 3 solutions. Okay, what about 2? 1 repeated. 1, 2. Good job, guys. What about 1? 1. That's for positive. 3 solutions. 2 and 1. 3. X-intercept, 2. X-intercept, and 1 repeated case is here. And what about going down graph? 1, 2, 3. Okay, please remember that. That's what you need to remember. All right, and make sure you're able to use it. Select the graph and table and go that part and put equation, tick box, select graph, and then you will get all the points here. You don't have to, that you will get that. Okay, you need to be able to do that. All right, section 6. So let's go. Do not draw sign diagram. I didn't teach that. They actually do plus and minus sign diagram. We don't need it. Okay, so we just cover page 274. Okay, we don't have much, so it's shorter classes. Question 9 is not in the test, so I'll just cover all together through 2 lessons. So we've done it. So this is a week 4 Monday class. Well done, guys. Well, you will come back in a week and I can teach you in front of you. That will be much nicer. Good job. Thank you.